In this video, we're going to look at how you could identify more metals, so more positive ions, as a result of their reactions with sodium hydroxide, okay? Now, it turns out that some of the metals, when you react them with sodium hydroxide, they produce something called a precipitate. And a precipitate is essentially when a solid is formed out of a solution. So let's have a look at this solution here on the left to begin with. Now what I'm going to do is I'm going to squeeze some of the sodium hydroxide solution into this using a pipette, okay? And when I pipette the sodium hydroxide solution into it, we should see a solid form, okay? And the colour of that solid will tell us what metal we've got. So this is sodium hydroxide solution test for metal ions. Let's have a look at this first one. Okay. So you can see a green solid is being formed here. That green solid tells me that I've got iron 2+. Okay, so Fe2+ ions. Okay, so that's an example of a green precipitate. So that's actually a solid that's formed there. That solid does actually change colour quite quickly, so it might have changed colour by the end of this, but we'll see. So the green precipitate, just to be clear, I'll just make some more of that appear now, so you can see that again. The green precipitate, there it is, beautiful, is iron 2, Fe2+ ions that solution contains. Okay, let's have a look at our next one then. I'm going to add some sodium hydroxide solution to this sort of orangey yellow looking solution here. Now you can see here I've got an orangey brown precipitate. And an orange-brown precipitate is indicative of iron 3+ ions. So iron 2+ gives green, iron 3+ gives a brown-orange precipitate. Okay, so that's actually a solid that's formed within that, and it's just broke off and is now falling to the bottom under its own weight. Let's have a look at the next one then, this sort of pale blue solution. Okay, again, we're going to add sodium hydroxide to the solution. Okay, you can see I'm getting this lovely blue precipitate now, and that blue precipitate tells me I'm working with copper ions, specifically copper 2+, Cu2+ ions. Okay, so just to recap, green precipitate, Fe2+, orange precipitate, Fe3+, blue precipitate, Cu2+. Now the final three all have something in common, so let's have a little look what we get. White, white, and white. So all three of these have given a white precipitate, and a white precipitate tells me it's either aluminium, calcium, or magnesium. So just to be clear, that's aluminium, calcium, or magnesium. Now, we can't distinguish between all three, but we can find one of those three by doing something very, very simple, which is to add an excess of the sodium hydroxide. Now, as I said, that it might either be aluminium, calcium, or magnesium, okay, with a white precipitate. If you add an excess of the sodium hydroxide solution, then only aluminium will redissolve. So I'm going to add an excess now, which means too much of. Aha. See, it's clearing somewhat. Let's just zoom in a little bit more for you guys. Just have a little bit more of an excess now. Boom. So you can see that the precipitate there has redissolved, and that tells me that this one here specifically is aluminium, because only aluminium will redissolve when we add an excess of the sodium hydroxide. You can see now if you look at the volume of it, I've clearly added way too much sodium hydroxide and it's caused it to redissolve. You might be thinking then, well, how could we go ahead and distinguish between the remaining magnesium and calcium? Well, you could run a flame test on them. And as we learned earlier, calcium will give an orange-red flame, whereas the magnesium would not. Okay, so we could run a flame test on it under a Bunsen burner, and we'd find that the calcium would give an orange-red flame, whereas the magnesium would not. So let's summarise what we've learned. Fe2+, iron 2, gives a green precipitate when we add sodium hydroxide. Iron 3+, Fe3+, gives an orangey brown precipitate when we add sodium hydroxide. Copper 2 ions, or copper 2 plus, Cu2 plus, gives a blue precipitate when we add our sodium hydroxide. And aluminium, magnesium and calcium all give white precipitates. Bear in mind they're not transition metals, makes sense why they're white. Okay, they all give white precipitates, but only the aluminium will redissolve when an excess of sodium hydroxide is added. And in order to distinguish between potentially magnesium or calcium, as you wouldn't know, you need to run a flame test, and the calcium would give an orange-red result, whereas the magnesium wouldn't really give a very clear result at all.